In this series, I'm going to be giving you AWS services that can take your career to the next level. I'll reveal those services which you must master if you want to be successful in your DevOps or in your cloud computing journey. Videos which we are going to be producing along this series are going to cover different job descriptions or different requirements which companies have to meet their needs. So you want to watch this video to the end, because based on the various services which we are going to cover, there are various job descriptions which you can use these services to apply for. A lot of people want to get started with AWS and they don't know which service is required for which particular role. So we'll be giving the various services that match different job descriptions. If you're not yet subscribed, hit the subscribe button right away and get subscribed to our channel. If you want to get yourself ready or you want to ace yourself up for your interview, you can hit the description and get a one-on-one mentorship call with me, and I'll be available to help you in your journey. Security is one of the best practices which must be implemented in any technology service or any technological setup. Well, on AWS, there are a given number of technologies which you can use to secure your infrastructure or your applications hosted on the AWS platform. I'll be focusing on some key security services that can help you to build a good security posture on your AWS environment. Now, when talking about security on AWS, the very first service that should come to your mind is the AWS Identity and Access Management Service, the AWS IAM service. Now, IAM service is one of the ways which you can use to federate or to manage access to your AWS environment. Given you have a certain number of developers or different teams and you want to manage who has access to what resource which your organization has or which your organization is hosting on the AWS cloud, you want to use the Identity and Access Management Service for that purpose. Now, if you're going for an interview and they have security as one of the key requirements of the talent which they are looking out for, you want to make sure you major on the AWS IAM service. Now, when talking about the AWS IAM service, the key aspects of IAM that should come to your mind. First, we have the IAM roles. Now, IAM roles enable us to give fine-grained access to users based on a given set of permissions. All right, you write these permissions using IAM policies, and the permissions specify which user has read or write or read-write access to given number of AWS services. So IAM roles and policies are one of the things which you must mention when talking about IAM. Also, you want to talk about the AWS multi-factor authentication for root accounts. So if you're having a root account and you want to ensure that it is secure, one of the ways which you can do is using the AWS MFA or setting up MFA for the root account. And also, you want to implement good strategies in your account settings as far as security is concerned, with strong password policies, as maybe using uppercase, lowercase, with good password rotation policies and all of that. So those are key things which you must mention as far as IAM and security is concerned. Let's dive right into the AWS console so you know what services or what IAM services for security are been mentioning on the AWS. So the very first service which you're going to be seeing as far as security is concerned is the IAM service, where IAM basically is the Identity and Access Management Service. So you can use IAM to manage access to AWS resources, and some of the top features which you have as far as IAM is concerned, we have groups, users, roles, policies, and access analyzer. So we'll get into the IAM console and then you see some of the key features which AWS has. The main features, of course, I mentioned groups, roles, policies, and access analyzer. So once you click on the IAM service, or once you click on IAM here, it's going to take you to the IAM dashboard, and with the IAM dashboard you have a summary of all the IAM related resources. You have a summary of all the IAM related resources which you have in your environment. So it gives you a summary of groups, a summary of users, a summary of roles, policies, and identity providers. You can equally see them here along these. And if you also want to manage account settings, you can manage your account settings at this level. Now, one of the key things which you understand as far as IAM is concerned is you can create users. Like if you want to onboard people into your environment, so you can create users. So here on the IAM, the key feature which you know is users, where you can create users. And IAM user basically is when you want to give long-term credentials. So for you to create a user, it's pretty straightforward. You click on add users, and once you click on add users, they're going to ask the username. For example, let's say DevOps with Mike. Now, once you click on DevOps in Mike, they'll ask if you want this user to have access to the IAM console like we are having, and if yes, you can. You just want to create the IAM user, and they'll ask you to give provide password. Probably you want to have a custom password, or you want the platform, or you want AWS to generate the password, so you can have a custom password, and then you can use users, or users must create a new password upon logging in. So basically, once you fill this information, all you need to do is to click on next, and the user will be the next. Once you click on next, they'll ask if you want to add this user to a particular group, if the user is existing, or if there's a group. Perhaps if you have a dev group, a prod group, or a testing group, or if you don't have a group, you can simply create a group here and you add this user to the group, and then you can add permissions to the users. Basically, permissions are like policies, or you can create a custom policy which you add to the user directly. So once you have, if you don't have any policy, for example, if you don't have any group, you don't necessarily need to select this, but you can add maybe one basic policy. If you want this user to be like or to have administrative access, you can just select on administrative access permissions here, and then you click on next. And the next thing which you have to configure is basically to review. Once you review all of these requirements, you just need to click on create user. Once you create user, or once you click on create user, it's going to provision a new user in your environment. So they say the user has been created, DevOps with Mike. They give you the console URL. You can copy this URL and or you can directly email the instructions for login to the user, and then this is the username and password. You can download these credentials, and then you can equally return to the list of users. So basically, well, they'll give you this. You haven't reviewed your password, so let me make sure. Let me continue, because I'll actually delete that user. Now once you create that user becomes part of your users. Now you can have groups, user groups, where you can group users based on the project which you're working on. You can create a group for prod, you can create a group for testing, you can, so these are different users. This is, maybe let's take for example the dev group. You might want to add DevOps in mind, which you just created, to that DevOps group, and you can have a given set of policies which you want everybody in that dev group to have. You attach such policy, and then you create group. That way you create a group. Anytime you want to add a user with these same policies, you don't need to provision new set of policies. All you need to do is to add a user to the group. And then the key features which you also have as far as IAM is concerned is roles. And a role basically is an identity you can create that has specific permissions with credentials that are valid for that, or for short-term duration. So if you don't want to have long-term access to a particular resource, you can use roles to create that access, or to create those conditions. Now once you want to create a role, all you need to do is click on create role, and once you click on create role, it'll give you some very important aspects. A trusted entity. Are you creating this role to allow services like EC2 to have action, or to take actions in your account? Are you creating this role to allow someone to have access to your account? Or are you trying to have web identity, or maybe trusted policy, and so on? So the moment you are setting all of these are just ways to specify what the role will be performing. So assuming I want to have to grant access maybe to a particular service, EC2. So it means that for this role, anytime I attach this role to any user, I can even specify I want access just to, let's say for example, we've selected EC2. So let's take for example, want this user to have access only to auto scaling. So you have to select EC2 and you click on auto scaling. So the moment you select auto scaling and you take next, every time, that's basic permissions which you've already added auto scaling. That's the basic permission which you've already added auto scaling permission. And once you click on next, it automatically gives this user the permission. You can review and create. You can give the name of the role where we've already given a name, and once you do that, you create a role. Now every time you attach this role to any user or any service or any identity, that user will have just the AWS IAM service role for auto scaling. So that is one of the key things which you must understand as far as security is concerned. It gives you the ability to give users just the necessary, or the least privilege mode, where they have just the required permissions to perform operations on a particular environment. Now policies basically are the sets of permissions, maybe allow, once. These are all AWS managed policies, and if you cannot use an AWS managed policy, you can create your own policy, which you definitely have to select your services that you want to allow users to have access to, or those which you want to deny users to have access to. You can use a visual editor, or you can just basically create everything as a JSON file and upload the JSON file, or create the policy using a JSON file. So that's basically it about policies. Now as far as IAM is concerned, the next most important thing which you must understand is the account settings. Now the account settings, it basically gives you several aspects of your account. We have password policy. If you want to implement a password policy, you can do that in the account settings. So for example, this account has password policies that the password must be 8 characters minimum. You must have lowercase, uppercase, numbercase, alphanumeric. The password never expires, must be edited, and so on. So basically all of these are some key aspects as far as security is concerned. You can edit your account settings so that for any given time the users will have some particular conditions to meet. So this is security posture, or this is a security discussion which you can also put in your interviews where you've configured account settings. And then we have another very important thing as far as users is concerned. We can go into a particular user, for example the DevOps in my user. You can configure certain other credentials as far as this user is concerned. Now as far as this user is concerned, you can assign what we call multi-factor authentication. Now with multi-factor authentication, only those who have multi-factor authentication assigned, or only an assigned MFA device, will give you access into this environment. And then you can equally assign secret and access key for CLI. So if you want to use or access your AWS account through the command line interface, you must configure secret and access key. Now if you want to perform code commit projects, like I mentioned in another video on AWS CI/CD, if you want to commit or perform code commit projects, you must create or upload an SSH. You can equally create Git credentials which you can use for your AWS code commit repositories, and as well you can create key spaces for your Apache, Cassandra, and so on. So all these are security postures which AWS puts in place to make sure that the least privilege, that means a user has just the right and the necessary security access for their given account. So you always want to summarize this and have these conversations during your interview or during your discussion on the IAM service as part of security. Now, the second security service which you must mention when talking about security during your interview or when studying AWS is to talk about the AWS Guard Duty. AWS Guard Duty. Now, Guard Duty is AWS service that helps to perform intelligent threat detection and monitoring of your environment. Okay, so you want to monitor unauthorized access or misconfigured credentials and malwares in your environment, you want to use the AWS Guard Duty. So Guard Duty gives you the possibility to perform intelligent threat detection in your AWS environment. Let's dive into the console and see what Guard Duty looks like. For you to know more about Guard Duty, you come to the services section here and you just type Guard Duty, and it's going to give you some search results about Guard Duty from all AWS services. And as you can see, Guard Duty helps in intelligent threat detection to protect your AWS account and your workloads. So for you to know more about Guard Duty, you can have guard trails, you can configure dashboards for control tower, you can have landing zone setup, and you can integrate all of them with Guard Duty for intelligent threat detection. So for us to have more idea, or for us to know more about this service, you just need to click on Guard Duty and it'll take you to the Guard Duty console. Okay, once you're on the Guard Duty console, what we can see here is Guard Duty is intelligent threat protection for accounts and workloads. And basically, as you can see, you can easily deploy and scale for up to 5,000 member accounts. You can have accurate machine learning detection. You can have up-to-date threat intelligence protection, and equally tightly integrated for fast response. So these are some common use cases: protecting compute like EC2 instances, protecting AWS credentials, and then protecting data stored in S3 buckets. So this is one of the key security services you want to mention. Then if you want to start Guard Duty, since it's a paid service, you can try the service for 30 days free trial. So if you want to try out the service, you click on Get Started. It's going to give you the opportunity to perform threat detection in your AWS account for 30 days. So maybe let's click on Get Started. Once you click on Get Started, it's going to give you the opportunity or the possibility to enable Guard Duty in this account. And once you click on Enable Guard Duty for 30 days, it's going to continuously keep track of the account. So that's basically it. It's going to analyze VPC flow logs, and now these are conversations which you can always have as far as Guard Duty is concerned. It's going to analyze your VPC flow logs. It's going to analyze AWS Cloud Tree Management event logs, DNS query logs, AWS Cloud Tree S3 data logs, Kubernetes audit logs, RES logging activities to generate security findings. So you want to mention all these, and it's equally going to analyze Elastic Block Store volume data to generate malware detection findings. So the next security service which you want to mention is the AWS Web Access firewall, or the AWS WAF. Now, AWS WAF helps you to monitor traffic coming into your applications from the application perspective. So at layer 7 of the Open System Interconnect model, the OSI model, we have the AWS WAF that intelligently monitors incoming traffic get towards your application. And with the WAF service, you can definitely allow or deny given set of IP addresses from accessing your application. Similar to the AWS WAF at the application level, we have the AWS Network Access Control List, or the AWS NACs. Now, AWS Network Access Control List are security services, or it's a security service that operates at the VPC level. And with this service, you can permit a given set of IP addresses using the allow or the deny role to specify which IP range has access to your AWS environment or not. Alright, so you want to use the AWS WAF for application security and the AWS Network Access Control List NACL for network security. And going further at the level of compute resources, you also want to implement the AWS security groups that have the right set of inbound and outbound rules that permit you to define which traffic gets or which set of IP addresses have access to your compute resources or not. So talking about security, again, we mentioned the AWS WAF, the AWS NACLs, and AWS security groups. Let's dive right into the console so you can have an idea on the WAF, the NACLs, and the security group service on AWS. AWS Web Access Firewall, the WAF service. And WAF basically is an opportunity for you to protect against malicious web traffic. So, well, I mentioned the other security service. You can see AWS Firewall Manager, AWS Web Architected Tool, AppFlow, and so on. But we are going to be looking at the AWS WAF service, the Web Access Firewall, as a security service on AWS. So all you need to do is just to click on WAF here, and it's going to take you to the AWS WAF and Shield dashboard. So we are on the AWS WAF Shield. We are on the AWS WAF dashboard, and you can see it protects your web applications from common web exploits. And well, you can use WAF for $5 per web access control list per month. You can use, so you can configure the role based on your applications, and these are some benefits which the WAF service has. And then these are some common related services which you can integrate WAF with. We can have AWS Shield, AWS Firewall Manager, AWS CloudWatch, and AWS Kinesis. So basically this is what the WAF service looks like on the console. You can configure your, well, you can start by basically creating a web access control list where you configure some intricacies as to the website or the resources where you don't want web access to, and you specify some of your roles. So basically you give a name, the description, the CloudWatch metric name, and then if you have some CloudFront distributions which you want to add, you can add it. You specify the region where you want to deploy this WAF, and then you're going to add resources, the resources that you associating that you don't want to have malicious access to. And after that, you have to configure the roles, which IP address has access, which IP address doesn't have. You can set the role priority, which role should run first, which IPs, or maybe should you first check these IPs before checking this next set of IPs before checking, and so on. So those are some configurations which you need to do, and after that all you need to do is to review and create. Now, as far as WAF is concerned, the other key thing which you should also understand is the IP set. So IP set basically is you don't necessarily need to be putting one and the same IP over, so you can group them as sets, and you can reuse them oftentimes as AWS, or you can use them oftentimes as a set. That's basically you defining the IPs which you want to have access to your account or not. Now, we also mentioned security groups as one of the key services that have to do with web access, or that has to do with traffic or IP address security into your network. So security groups support at the EC2 level, and well, they're available at the EC2 level and at the VPC level. So once you're on your VPC console, you can have access to security groups, and once you're on your EC2 console, you can equally have access to security under your network and security settings. So the main way to secure your EC2 instances often is using security groups, and then you can also configure security groups in VPCs under security groups. So basically, security groups, like we discussed, gives you the possibility to give a set of, or to specify a set of IP addresses that come into or out of your resources. So for example, let's give a security group name DevOps. This is DevOps with Mike security group, and then you can give description. For example, allow SSH to developers. So if you want developers, so you can see, say allow SSH to developers. Now SSH is a protocol which you can use to access your terminal. So now SSH operates on port 22. So if you want to add that security group rule, you need to just click on add the rule. Now are you saying that once you click on add the rule, you have to specify the type of traffic? Do you want TCP traffic, UDP, ICMP, custom protocol, or you want particular SSH, SMTP, depending on your protocol? So you need to specify the type of traffic. So assuming you want just SSH traffic into our resources, you need to click on SSH. Now SSH basically is operating on the protocol TCP and on port 22. Now which traffic source do you have or do you want? Are you saying that anywhere traffic is coming from the internet, you want to grant access, or anywhere traffic is coming from IP version 6 or from your computer? So if you say you want traffic from anywhere, or you can customly specify the port which you want to have traffic accessing your resources from. So once you click on anywhere, it means internet or traffic coming from anywhere in the internet will have access to your resources that are protected by this security group. And you can equally just add a simple description, and then you put the description as well. So once you allow this, you have SSH, TCP, port 22 as allowing traffic to anywhere, or allowing traffic from anywhere to our resource. So once you finish configuring this, you just need to click on create security group, and your security group will be created. Now once you create the security group, you can now use the security group to attach to maybe instances. Remember, this is here we are on the AWS EC2 dashboard, and on the EC2 dashboard you always see security groups, because instances or compute resources always can be protected using security groups. Now security groups is another very important security feature which you should always have conversations around. Now also, as far as security or at the VPC level, we also have the network access control list. Now security groups, like we said, is a compute level security tool, but if you want to secure your traffic entering at the network level, you can then use what we call network access control list. The first one, we had web access control list for traffic entering into your network, but for this we are controlling network entering or traffic entering into our network at the VPC level. So you can configure network access control list at the VPC level, and you can now configure security groups for your compute level security. Now once you click on create network access control list, just like security groups, you need to give the name. So for example, we give the name DevOps with Mike network access, DevOps with Mike network access control list, and then you specify what VPC, because like I said, it's VPC level security, so it's going to be securing traffic that is getting into your VPC. Now once you click on network or create network access control list, it's going to create the network access control list. Now once you have this network access control list, DevOps with Mike network access control list, you can then edit inbound rules. Same like you can edit inbound rules, just like we had inbound rules for our security groups. Now with these inbound rules, the difference is you need to specify the role numbers. So there's a difference between security group and network access control list, one being stateless and one being stateful. The network access control list is stateless, meaning you need to, any traffic you allow inbound, you must allow the traffic outbound. Unlike security group, which are stateful, where for every traffic you allow by default already has the outbound rule. So for network access control list, you just need to add a role, and will be implemented based on the rules. So you can have maybe rule 100, you want maybe custom TCP IP, or let's say SSH on port 22, and you're allowing, and you're saying anywhere internet, anywhere or any traffic coming from the internet on port 22, the rule is allow, or the rule might be deny. So any traffic coming to your VPC on port 22, you're already going to configure if you should allow this traffic or if you should deny this traffic. So that is how you can use network access control list, web access control list, and web access firewalls, WAF, to control access into and out of your environments for a good security posture. The next security service you want to mention is the AWS Secrets Manager. AWS Secrets Manager helps you to store your secrets on the AWS platform. So if you have some secret passwords, secret API keys, or secret URLs, or whatever the key is, database passwords, database credentials, endpoints that you want to store in the AWS cloud, the AWS Secrets Manager is a security service which you can use to effectively manage secrets on the AWS cloud. So when talking about security services, you must mention the AWS Secrets Manager. Once you're on the AWS console and you want to search for secrets managers, and secret manager basically auto completes for you. Say secret manager helps you to easily rotate, manage, and retrieve secrets through their entire life cycle. So all you need to do is to create secrets, and key features is just basically management of secrets. Secret might be database passwords, might be database endpoints, might be usernames, and all of that, which might be part of your environment. So once you click on this secrets manager, it's going to take you to the secrets manager console. So here we are on the secrets manager console, and basically how it works is you can use secrets manager to store, rotate, monitor, and control access to secrets such as, like I mentioned, database credentials, API keys, auth tokens. It enables secrets rotation between your MySQL, Postgre, Aurora, or RDS databases, and it's pay as you go. It's a managed service. It's also you can equally relate it, or you can actually integrate it with relational database service RDS. You can integrate with AWS Lambda and Code Guru. So basically, for you to store a secret is $0.04 per month, and then per $0.05 for 10,000 API calls. So once you store the secret, for every time you do an API call to use the secret, it's going to cost you $0.05, and then you can have a 30 days trial. So basically, for you to store a new secret, you just click on store a new secret. They're going to ask you what type of secret are you trying to store. Is it a credentials for an RDS database? Is it credentials for document DB database? Is it credentials for Amazon Redshift cluster? Is it credentials for database, or is it for any other API key? So assuming you want to store credentials for RDS database, you just need to give the name of the user, probably just give admin, and then the password admin 1234. If you want to see the password, you can confirm by clicking the show password, and you see admin 1234. Now, what type of encryption? If you have, well, we'll talk about encryption. You have an encryption key, you can attach encryption to this password, and then you can maybe specify the database which this password will be attached to, or which this username will be used in accessing. So once you highlight this, you just need to click on next. We don't have any database in our account, that is why you cannot have access to this. But for you to basically store secrets that will be used in accessing that database, you can create a database and then you perform this trial. So we have secrets manager to manage secrets stored in our AWS account. Next security service which we are mentioning in this video is the AWS Shield. AWS Shield, and AWS Shield is a service which you can use to prevent dedicated denial of service attacks. So if you want to prevent DDoS attacks that are coming, or that is geared towards your applications, you can use the AWS Shield service. So AWS Shield service for denial of service attacks. And the last service for security which you must mention in your AWS interview, or which you must mention in interviews, or which you should learn if you're starting your journey on AWS, is the AWS Key Management Service, the AWS KMS. And KMS helps you to create, manage, and delete encryption keys that can be used to secure your data in the AWS cloud. Now, you also want to use this AWS, or you want to use these encryption keys to secure your S3 buckets, or data stored in your S3 buckets, or data stored in your Elastic Block stores, or data stored in your Elastic File system. So the AWS Key Management System, the KMS, helps you to manage encryption keys that will be used to secure your data that is being encrypted. So you just need to type shield, or you can type AWS Shield, and it's going to show you it's still under the WAF, so it protects DDoS attacks and malicious web traffic. So once you click on this, it's going to take you to the AWS Shield console, and AWS Shield is a managed dedicated denial of service DDoS protection service. So it provides continuous attack detection and automatic mitigations, and AWS Shield offers two tiers protection, the standard and the advanced. So if you want to go around testing it, you can subscribe to the advanced, or you can basically use the standard. Now, the advanced gives you the possibility of paying $3,000 a month, and then you can equally add it to your AWS account or to your AWS organization, where all accounts connected to your AWS organization will have this protection. Now, basically, for small overview, you can subscribe to the Shield Advanced. To get the benefits of the Shield, you must subscribe basically, and then you can set up protection for your CloudFront distributions, protection for your load balancers, protection for your elastic IPs, protection for your Route 53 and global accelerators. Now, these are all methods which can be used to access resources in your AWS account. So the AWS Shield will be used to protect these resources: CloudFront distribution, load balancers, elastic IPs, Route 53 hosted zones, global accelerators, which are the entry points to resources in your application. So you always want to make sure you have a good conversation on the usage or configuration of AWS Shield to protect your load balancers, to protect your elastic IPs, to protect your CloudFront distributions, and to protect your global accelerators and your Route 53 hosted zone. So this gives you a more detail on some of the ways which you can use AWS Shield to set up a good security posture in your environment. Last service, which is the AWS Key Management Service, the AWS KMS. Now, KMS helps you to securely generate and manage AWS encryption keys. So you want to encrypt maybe data in your S3 buckets, in your ABS volumes, or whatever data you want to encrypt. You can use the AWS Key Management Service, and some of the top features are with AWS Managed Keys, Customer Managed Keys, and Customer Key Store. So once you want to access this service, you just need to click on KMS, and it's going to take you to the KMS console. So we are on the KMS console, and you can easily create your encryption keys and control encryption keys around or across AWS and even beyond AWS platform as a whole. And these are some key benefits: fully managed, centralized key management, built-in auditing, no commitment, compliance, secure. And then you can use it with cloud HSM. You can use the AWS Certificate Manager and Encryption SDK. So for you to create a new key, you can click on create a key by just selecting that. And then do you want a symmetric key or you want an asymmetric key? So if you want a symmetric key, or depending on the requirement, you can then specify, do you want to encrypt and you want to use the key for encryption and decryption, or you want to use generate your own key or your own message authentication codes. So once you click on that, you can now start configuring some of the key things, defining key administrative permissions, defining key usage permissions, and all of that. So this is the key management service which you can use to manage encryption keys that will be used to protect your resources on the AWS console. So guys, those are the key security services which I believe if you have a mastery of during your technical interviews, you have a good discussion as far as security on AWS is concerned. Every cloud provider has storage as one of the major services which they sell to their customers, and by default it is important for a cloud technology expert to master some storage services as one of their key requirements to be successful. If you are a starter and you're wondering how to implement storage services, this video will give you an understanding on the key storage services available on the AWS cloud. One very key thing I want to bring to your understanding as far as storage is concerned on the AWS cloud is there is a partition of storage based on the type of data that is being stored. Now we can have data that is stored as objects on the AWS cloud, or we can have data that is stored in a block on AWS cloud. Based on the data that is being stored, either be objects or blocks, there are different technologies made to solve that given storage requirement. To begin, I'm going to cover the first storage service, which is an object storage on AWS, which is Amazon S3. Now Amazon S3 simple storage service is one of Amazon's flagship storage for object-based storage on the AWS cloud, and S3 gives many companies the ability to store terabytes of data on the AWS cloud at a very moderate cost. Now AWS has different ways in which you can access, store, and modify or edit your data that is being stored on the AWS cloud. And as far as you mention your experience with Amazon S3, the key thing which you should always have understanding of is the data access patterns. And based on the data access pattern, you can specify or you can recommend a given particular AWS S3 storage over another. We have the S3 standard storage, storage, which is for data that is frequently accessed and frequently used, which you can store with the AWS S3 standard class. We also have the AWS S3 intelligent tiering for data with an unknown access pattern. So assuming you want to move your data to AWS S3 and you're not sure of how frequent that data will be accessed, you want to use the AWS S3 intelligent tiering. Now, for data that you're sure that you're going to store long term in your AWS S3, you want to use the AWS Glacier. And as far as Glacier is concerned, we have also the frequently accessed or the infrequently accessed, and we have the deep Glacier. So those are some key S3 storage classes. And also we have the lifecycle manager on S3 that can help you to manage data that is stored in your S3 bucket. That way you'll be able to know how to transition your data from a given class to another based on the access patterns or the access. So you having a good understanding of S3 is a good requirement for you to understand the AWS cloud. And as far as S3 is concerned, almost all AWS services use the Amazon S3, because when you collect logs with monitoring services like CloudWatch or CloudTrail, you want to store those logs in your S3 bucket. And a lot more of other services, they're all interconnected. Maybe you want to save a static website, you can store that in an S3 bucket, and then you can use CloudFront to expose that website to users using CloudFront distribution. So S3 is one of the key storage services which Amazon has, which you must have an understanding of. Well, let's dive right into our AWS console to see a little bit about Amazon S3 and how you can use, or what are the key intricacies of the Amazon S3.
Once you're on the AWS dashboard, you can explore. Now, if you come to the search bar here, you can actually search for S3, which is the very first service which you mentioned. And once you search S3, you can see it's going to give you various options. S3 scalable storage in the cloud, archive storage in the cloud. And so also we're going to choose S3 as the option which you want to explore first. Now, once you click on S3, it's going to take you to the S3 console. Now, S3 basically, as I said, is and gives you the opportunity to store and retrieve any amount of data from anywhere. And once you're on S3, you can read through the documentation very briefly. It gives you some of the benefits, data performance and durability, and all of that. So use cases, backup and restore, disaster recovery, archive, data lakes, and big data analytics, hybrid cloud native applications, and so on. And they give you some case studies. We have Georgia Pacific, Nasdaq, Cisco, Nestle. So this is some companies that are using AWS S3. So you can come to the AWS console as we are now. So for you to make use of AWS S3, here's some key things which you should note: bucket, access points, object lambda, access point, multi-region access points, and so on. So for you to create a bucket on S3, all you need to do is just click on create bucket, and it's going to give you some information to fill. So you need to give a bucket name, and bucket names on S3 are unique. That means no two buckets on the AWS console or AWS platform are supposed to have the same name. So let's just give a very random name, DevOps. Let's give a simple name, DevOps with Mike, DevOps and Mike, S3 bucket, Oregon region. So this is saying we're going to be creating a bucket, and like I said, bucket name must be unique within the global namespace following naming rules. So you can check out naming rules, and then when select, you specify the AWS region where you want to create the bucket. If you have some existing buckets, you can copy bucket settings and then you configure it once creating the bucket. Now, access control list is basically how you manage access to your bucket, and then we equally have the possibility of you blocking public access or like restricting people from accessing your buckets generally. So all those settings are in the public block access. And then versioning basically is a method for you to keep track of your bucket such that you cannot lose content, or you cannot you can have versions of your bucket versioning is an opportunity for you to have disaster recovery so that you don't lose data, or maybe you can restore data to a particular given point. And then also S3 gives the possibility to encrypt data based on different encryption types, server side, client side, and so on. So these are some options. Now once you give the bucket name, all you need to do is to, once you see all these options, all you need to do is to click on create bucket. And once you click on create bucket, automatically you're going to have the opportunity to create bucket. You see, after creating the bucket, you see we have successfully created our first or we have successfully created a bucket there with my buckets, and if you want to view the details in the bucket, you click on new details, it will give you the details, and basically we do not have any item in this bucket. So if you have to store objects, all you need to do is to click on upload, and once you choose upload, they're going to ask you if you want to upload a file, or you want to add folders and so on. So if you choose, for example, you want to add a file, once you click on add file, a pop-up will come where you have to select file maybe on your local and so on. So assuming I want to add this file maybe in CloudFormation template, the VPC ALB stack, all I need to do is to select this file and I click on open, and then it's going to upload this file into my S3 bucket. So you see drag and drop files. So you see this file VPC has been uploaded, or it has been selected to be uploaded, and once you click on upload, you upload this file into the bucket. They tell you successfully or succeeded 0 files and 0 files. So once you complete that, you see they've already stored that file in the S3 bucket. So this is one of the services which you can use, like we mentioned, to store data on AWS.
Now, the next storage service which AWS has is a block storage on AWS, and we have the Amazon Elastic Block Store, EBS. So EBS actually enables you to store data in blocks, which we call volumes. Now, EBS volumes give you a lot of flexibility as far as data storage is concerned. And when you talk about Amazon Elastic Block Store, there are a lot of integrations which you have. Now, with your Amazon Elastic Block Store, you can use to store settings and configurations of your Elastic Compute Cloud of your EC2 instances. And with this block store, you can effectively produce Amazon machine images, which can be used to spin up instances. Some call them golden AMIs. You can use your block stores to produce golden AMIs that can be used to spin up new instances. Now, also with the Amazon Elastic Block Store, you have the ability to copy the configuration data of your EC2 instances from one region to another, and you can enable multi-availability zone deployment of your infrastructure using Amazon Elastic Block Store. So EBS volumes are one of the most important things which you should understand as far as Elastic Compute Cloud is concerned, and equally one of the widely used flagship storage offers on AWS.
So come to AWS console, all you need to do is search EBS. Now, Elastic Block Store is a compute or is a block storage that is found under EC2. So once you click on EBS, or once you type EBS, you click on EC2, you give you the opportunity, you give you the possibility to come to the EC2 console where you have options for managing Elastic Block Storage. And once you're on the EC2 console, you can see we have Elastic Block Store. And we have under Elastic Block Store, we can have volumes, we can have snapshots and lifecycle manager. So once you click on volumes, it will give you the opportunity to create a volume, and this volume is what we call the Elastic Block Store, where you can store data of a given capacity. So assuming we want to create a new volume to store data, and which of course we can eventually attach to an EC2 instance, all we need to do is to click on create volume, and once you click on create volume, we'll ask you the volume type based on the various volume type. We have SSD, we have HDD and co. So these are all different volume types. So once you select a particular volume type, you can select the size, maybe you want a 100 gigabyte or 1 terabyte and so on. You can select the input output speed, IOPS, and then you select the availability zone where you want the bucket to be created. If you want this volume, select the availability zone where you want the volume to be created, and if you want this volume to be encrypted, you can maybe highlight the encryption, and then if you have an encryption key, you will have to select the encryption key. So we don't have any encryption key, so we will not be selecting encrypt. So when you select all these options, all you need to do is to click on create volume, and you'll see this volume is created successfully. Once you create this volume, this is the volume which we created. Once you create this volume, they'll tell you, oh no, it's not the one we created. This is the volume which you created, where of course you can rename this volume. Let's see, DevOps with mic EBS volume. Once you create this volume, you can see that you have different options here. You can create a snapshot from this volume, you can delete the volume, you can attach this volume to an EC2 instance, and so on. So these are some options which you can have once you have a volume or create a volume on the EBS or Elastic Block Store. And now clicking on Lifecycle Manager, which is snapshots. Let me start with snapshot basically is a way which you can use for disaster recovery to keep different track or to keep update or to keep updated track of your current EBS volume. So if I click on create snapshot, you definitely have to specify if you want to create a snapshot of a volume or of an instance. So these are ways which you can use for disaster recovery. Now the last thing which you want to mention as far as EBS is concerned is Lifecycle Manager. And Lifecycle Manager basically gives you the opportunity to automate the creation, retention, copy and deletion of snapshots and Amazon machine image in AMIs. So all you need to do is maybe you want to create a snapshot policy depending on how you want to be like keeping snapshots or different shots of your volume. So this is these are some very basics on EBS which you can go through just to have a better understanding on the Elastic Block Store.
The last service which I think is most important as far as storage is concerned on AWS is the Amazon Elastic File System. Now with the Elastic Block Storage EBS, you have the ability to attach an EBS volume maybe to a single instance. That instance will be using data that is stored in that given S3 bucket. But assuming you want to store a given block storage to multiple instances, you can then use the Elastic File System, the EFS. Now the Elastic File System gives you the ability to have mount points which you can use to mount that same drive or that same volume to multiple instances. So multiple instances will have access to your data or to your application information or to whatever you stored in that block volume at the same time. Whereas with the Elastic Block Store, a particular volume can be attached to just a single EC2 instance.
Elastic File System. Well, you click on Elastic File System, all of that is abbreviated as EFS. Now EFS is a managed file storage for EC2. So like I said, the difference between EFS and EBS is with EFS or with the Elastic File System you can attach to multiple EC2 volumes, while with the EBS you can attach only to a single EC2 volume. And Elastic File System is a scalable Elastic Cloud Native network file system, so it gives you the ability to create a volume or a storage that can be accessed by different resources in a network. So you can see different benefits, related services, data backup, AWS Fargate, Lambda, data transfer, and so on. And then these are the key things which you have to take note. If you want to create a file system, all we need to do is to click on create file system and it will give you a name. Depending on what you want to create, you can give a file system name. So let's say DevOps with Mike file system, and once you click on the option My System, you have to specify which VPC or which virtual cloud you want to create this file system in. And once you select, maybe you want to do in the default, once you click on create, you create the file system and it will give you the possibility to add resources into, like highlighting this, you give you the possibility to mount this file system on different EC2 instances. Or like you can see, I can attach this file. If I click on attach, I can attach this network file system to select different mount target. So it gives you a command where once you have an EC2 instance, you run this basic commands, it will give you the possibility to attach this volume into an EC2 instance. So these are just the basics of the same storage system which you can have as far as AWS cloud is concerned.
These are the key storage services which I believe you must mention when sharing your experience on storage on the AWS cloud. First, you mention your experience with S3, talking about the various S3 storage classes and why you choose a particular storage class. And then you go on to talk about the Amazon Elastic Block Store, the EBS volumes, and how you've created EBS volumes, how you've been able to convert those EBS volumes to Amazon machine images, and how you've equally used those images to spin up new instances. And lastly, you want to talk about the Amazon Elastic File System for the management of different or for the synchronous mounting of the same volume to multiple compute resources. Networking is one of the most important concepts which every cloud provider looks out for when deploying their services. Now, what are those key services that have to do with networking as far as Amazon Web Services is concerned? And this is one of the key questions which they always ask during DevOps interviews or during cloud computing interviews. Now, the very first service which we are mentioning or which I'm mentioning on AWS networking is the AWS Virtual Private Clouds. So the AWS VPCs or the virtual private clouds enable you to create cloud environments or to create your own virtual cloud environments on the AWS cloud. And as far as virtual private clouds are concerned, we have a lot of services on AWS that can interact together with your virtual private clouds. That is to say, You can build subunits of your virtual cloud using what we call subnets. Now for subnets, subnets are like smaller partitions of your bigger network or smaller networks of your main private cloud which you have. So we can have subnets that are accessible to the internet, which we call public subnets, as well as subnets that are not accessible to anyone from the internet, which we call the private subnets. So you can have private subnets and public subnets on your AWS environment. On AWS, we also have a service called Internet Gateways, which act actually as a firewall that helps you to have access to internet resources. So the internet gateway is what you add to a subnet to make it a public subnet. And well, for resources that are hosted in your public subnet and you want your users to have access to some of these resources, you now want to expose these resources to the internet using what we call the internet NAT gateway. So the NAT gateway on AWS is what makes you to have access to the internet from your private subnet. Now, well, as far as VPCs are concerned, or virtual private clouds are concerned, you can connect one or two VPCs using the VPC peering connection, or you can use the transit gateways that will enable you to connect two or more VPCs. So these are some key things, and equally route tables, which helps you to manage routes between the various resources that you store in your VPC. All right, so you have route tables that you specify which resource has, or which IP address has access to your resources.
To check out the very first service VPC, all you need to do is to type virtual private cloud or virtual private cloud. Once you click on virtual private cloud, the first thing which you can see is the VPC, which we talk about. So you can see VPC, subnets, route tables, internet gateways, egress only internet gateways. So we are going to be working on the VPC service, and for you to know more about the VPC service, or there are other networking services like I mentioned, you can have VPC lattice, transit gateway, analyzer, and so on. But well, we are focusing just on the service that is most required, or that knowledge of is required in the interview. So we'll click on the VPC, which is the main service that is often or required, or well, that need knowledge on as far as interviewing is concerned. So this is the VPC dashboard, or this is what the VPC dashboard looks like, and it lists out some of the virtual private cloud services that AWS has. And as far as virtual private cloud is concerned, we have, well, this is a summary. We have VPCs, we have subnets, route tables, internet gateways, DHCP sets, elastic IPs, endpoints, site-to-site VPNs, virtual private gateways, customer gateways, security groups, network access controllers, VPC pairings, NAT gateways. So all these are key VPC services which you should understand, right? So once you're on your, maybe you want to create a new VPC, or you need to, well, this is showing some of the VPCs that are existing, or what. Once you click on VPCs, it shows you some of the VPCs that are existing. So to create a new VPC, all you need to do is to click on create VPC. And now when creating the VPC, you can give the VPC name. So I'm going to give the name DevOps with Mike VPC. Now if you want to select, if you actually want to configure your VPC creation alone, or if you want to be in charge of the configuration, which is what we want to do, you choose the VPC alone. But if you want to add other components like subnets, route tables, and all of that, so you can, if you take VPC and more, it's going to give you the VPC, the subnets, public subnets, private subnets. It's going to give you route tables, internet gateway, network connections, and so on. So you can click on, you can equally, when creating the VPC, you can take VPC and more just to test creation of VPC with all these other components, or you can just take VPC only. Now if you take VPC only, you have to specify the IP address range of your VPC, and well, you can check out VPC site that, but we're just going to give it a random range 11.0.0.0/24 or /16. That'll be the range of the VPC. And if you want it to be in a particular, well, you don't choose dedicated is for VPCs that are kind of, you have special requirements. So once you have selected just these basic things, all you need to do is to create virtual private cloud or create VPC. Now once you create the VPC, of course, it will give you a successful note. You have successfully created
Of course, it gives you a successful node with a lot of details about the VPC. You successfully created your VPC. It gives you the ID which you can use to reference the VPC in the to use in other resources or with other resources. It gives you a lot of other information about the VPC, or the name and everything. So if you want to configure, gives you the CIDRs, information about internet routing. And then if you want to configure logs to track how traffic is moving in between the network or in between the virtual private cloud, you can configure that using flow logs. Now, as far as VPCs are concerned, the next thing which you can have is what we call subnet. And subnet is a smaller grouping of, a smaller subset of the VPC, or a smaller network. You can create different networks based, or you can create subnets based on your requirements. So for you to see how subnet works, all you need to do is click on create subnet. And subnets don't exist out of a VPC, so you must select the VPC where you're creating your subnet. So we're selecting the subnet for DevOps with my VPC, and then you give details of the subnet. Maybe if you want it to be a public subnet, you call it public subnet, and then you specify if you want it to be in a particular availability zone, you give a particular availability zone where you want it. But if you don't have, just allow no preference. And then now you can set up the CIDR block, say for example 11.0.0.0/24 for the CIDR block of the subnet, and then you can create a subnet. So once you click on create subnet, it's going to create, it might take a minute or so for you to create the subnet, and it says you've successfully created a public subnet, and it gives you some of the details which you can have or which you can use to reference the subnet. So that is how you can group networks into smaller network. You can group connections, or you can group your network into smaller networks. Now, route table is basically the way which you use to route traffic between your VPC. So for you to route traffic in between that VPC which you've created, probably you need to create a route table. And creating a route table is very simple. You can still give the same name, DevOps with my route table, and then you select the VPC which you are creating a route table for, and then now you create route table. Now route tables are attached to subnets, so you see we have successfully created this route table. Now route tables are always associated to subnet, so for you to associate this route table to a subnet is pretty straightforward. You click on subnet associations, and you see that this route table is not associated to any subnet yet. So for you to do that, you just click on edit associations, and then it's going to tell you, you can now attach this public subnet to that route table. So once you click on save associations, it automatically associates or adds this route table to that subnet, or it says that you can use this route table to access resources in that subnet. Now for you to make that a particular subnet accessible to the internet, you need to configure what we call an internet gateway. Internet gateways is what gives you opportunity to connect your resources in your VPCs to the outside world. So for you to create a public subnet, you need an internet gateway, and for you to do that, you just need to click on create internet gateway. You give the name of the internet gateway to DevOps with my internet gateway, and then now you create internet gateway. Now internet gateways are attached to VPCs. Okay, so if you want to attach these, once you create it, they'll definitely tell you want to attach it to a particular VPC. You click on attach to VPC, and then you select the VPC among the existing list of VPCs. So it's going to scan VPCs in your environment, and it's going to give you, so we choose the DevOps in my VPC, so it's going to add it to that, or you attach it to that VPC. Now once you attach it to the VPC, for you to configure routes now where traffic can move from your VPC, or someone can access your VPC from outside the wall, all you need to do to come to your route tables again, and then you select a particular route table. So we had created, and then you select a particular route table. So all you need to do is click on this route table, click on routes. Then now you can edit routes, you can add a route to the internet. Basically, you can add a route to the internet which is 0.0.0. You want to use the internet gateway which you just created, and then you want to select the particular internet gateway, DevOps my internet gateway, and then you want to save settings. That definitely means that this network which you've created, giving it access to the outside world. Now there are other key services which you should take note of as far as internet gateways is concerned. First, we have elastic IPs. Elastic IPs is one of the ways which you can use to have a static or allocate a static IP address to your resources. So if I want a particular IP address which doesn't change, you can do that by allocating an elastic IP. it's a service that costs a lot, so I will not recommend you allocating an elastic IP for a start. And they will also have endpoints, which endpoints is kind of a security level where you can use endpoints. You can create endpoints to access or to manage interconnection between some resources in your EC2 or in your network. So if you want to use endpoints for your AWS services, you can use that. You can use it to connect your EC2 instances and a lot more. So endpoints gives you that flexibility to connect secure connection or private DNS connection to your VPC resources. Now, another very important service you should take note of is the NAT gateways. And NAT gateways basically is one of the key ways which you can use to, we have created a subnet, and that subnet was actually public. For you to create a subnet that is private, it means no one in the internet has access to that subnet. And now if you want to perform changes or fixes within the subnet without necessarily going to give traffic or without necessarily providing access to the subnet, you can configure a NAT gateway, and this NAT gateway is what makes a private subnet to have access to the internet. So you always want to take note of the NAT gateway. And we also have peering connections which you can use to pair or to connect one or two VPCs together. Now, as far as VPCs or virtual private cloud is concerned, you also want to take note of network access control list, NACLs. Network access control list is one of the ways which you can use to control access or security into or out of your VPC. So if you want to create a particular network access control list, all you need to do is to click on create network access control list. You can give the name, say DevOps with Mike network access control list. Now you select the VPC where you want to perform VPC level security. You take DevOps with Mike, and then you create network access control list. Now, what makes it unique while it's being created, what makes it unique is the fact that you can select a particular range of IPs which you don't want to have access or which you don't want to ground access to, and then you now use that. So you configure which traffic you have access to, or you configure which traffic has access into and out of your network using the inbound and outbound rules, and then you also associate it to subnets. So you should take note of network access control list. You also have security groups which you can use to secure. You can create your own security group which you can use to secure your resources, especially resources like EC2s. So the last things which I want to mention as far as virtual private cloud is concerned is transit gateways. Transit gateways, we mentioned above that you can have VPC peering for if you want to connect one or two VPCs together. With transit gateways, the transit gateway gives you the possibility of connecting two or more VPCs together, where you can have a central, in a hub and spoke model, where you can have a central hub or a central device or a central transit gateway connecting 2, 3, 4 and so on VPC. So that's another service which you should take note as far as networking is concerned. So these are some key aspects of virtual private cloud which I think you should understand.
The next networking service or content delivery network service which you have on the AWS cloud that enables you to route traffic between your resources is the AWS Route 53. So Route 53, AWS Route 53 is a managed domain name service which AWS has for the management and resolution of your domain names on the AWS cloud. So assuming you have your resources in your AWS environment and you want resources to intercommunicate with each other, you can use a Route 53 service where you'll be creating records for resources in your AWS cloud. And well, if you want to have other resources outside the AWS cloud, you can equally use the Route 53 service to access domains that are outside AWS cloud. Route 53 also gives you the ability to route traffic based on your user location or based on your latency requirements, or well, your fault tolerance requirements of your environment. So you can use those Route 53 services that take into consideration your proximity of your users and the fault tolerance of your application, all the availability, general availability of your application. So you want to visit AWS Route 53 to have an idea on how domain name resolution is done on AWS cloud.
Route 53 is one of the other key services which is very much used as far as networking is concerned. And once you're on the AWS console, all you need to do is to search Route 53 and you'll have access to, you see we have Route 53 and they give you information on Route 53. See Route 53 is DNS queries or resolve DNS queries.
scalable domain name registration, monitor application business, and all of that. So it's actually a service for domain name resolution on AWS. So if you want to know more about Route 53, all you need to do is to click on Route 53, and it will take you to the Route 53 console, where you can now configure your domain names. For example, you see you can register a domain, and you can equally import a domain and all related services. As far as domains are concerned, you can do that. So you can register a domain, maybe www.devopsmike.net or www. whatever the case. You can register that domain here on Route 53. So it's a very important networking service which you must have an understanding of. Now, once you have your register, you can also view domains which you've registered. So once you click on that, it's going to give you, it will take you to the domains. So any domain which you've registered on AWS using this Route 53, you can view this registered, or you can view this Route 53 domains, and all of this is a way to keep track of domains which you are currently managing, and so on. Now, traffic flow is another very important thing which you should take note of, because we've not viewed or we've not registered any given domain yet. There are a lot of functionalities which you cannot see yet, but now basically these traffic policies gives you a method which you can use to route traffic. I will let you visualize or create routing configurations for your traffic from the internet, or from the point where somebody hits that domain www.devopsmike.net to the point where their content in an S3 bucket or in an elastic load balancer is being served. So you want to take note of these traffic policies, and you want to take note of policy. So the traffic policies, for example, give you options which you can use to create traffic, or which you can use to create methods in which traffic will be used to route to your resources. So if they type a given domain which I already mentioned, the traffic policy will determine which row will be used and which criteria under that row will be used, and how they will be used, and how they will be accessed, or how your resources will be accessed. So you want to take note of some of these traffic policies and just play around them if you have a registered domain, to test a lot of functionalities on Route 53. And then the last thing which you should see, or which you should know as far as Route 53 is concerned, is the policy records. Which is just basically giving you, maybe if you're using an A record or an AAA record or a CNAME record. So you also want to check out Route 53 record. So this is a very basic on Route 53, and I feel like you should understand Route 53 before going in for your interviews.
The next networking service which we'll talk about as far as AWS Cloud is concerned is the Elastic Load Balancer. The Elastic Load Balancer. Now, the Elastic Load Balancer on AWS is one of the key services that helps to manage incoming traffic to your applications hosted on AWS. Well, as far as load balancers are concerned on AWS, we have the AWS Classic Load Balancer, and then we have the Application Load Balancer, and we equally have the Network Load Balancer, all of which meet different requirements as far as load balancing is concerned. Now, the primary focus, or the primary reason why we want to mention load balancing, is because you can use load balancing as a method to manage or to route traffic between your resources to meet high availability and high scalability of your application. So the moment you're talking about AWS networking services, you must mention Elastic Load Balancer as an approach to manage traffic that is coming to your applications hosted on AWS Cloud.
Balancers basically is one of the networking services which is used to route traffic between a fleet of EC2 instances. That's why you find it under virtual servers, because if you have a fleet of EC2 instances or compute resources, you can use the load balancers for the routing of traffic between your compute resources. So once you click on load balancers, it will give you the opportunity to create a load balancer, to create load balancer technologies on AWS. As far as load balancers are concerned, you can, well, like it says, you can, an Elastic Load Balancer scales your load balancer capacity automatically in response to incoming or changes in incoming traffic. So I mentioned load balancers are used to manage traffic in between resources, or between resources in your environment. Now, for you to put the resources together, we configure what we call target groups. The target groups is a logical grouping of a fleet of EC2 instances or compute resources that you want to be managed by your application load balancer. And when you click on create target group, for example, they are going to ask you to fill in some information. If you like, we can see here, these are some of the basic configurations for a target group. You want to maybe configure EC2 instances as targets for your load balancer, or you want to configure a given set of IP addresses as targets for your load balancer, or a given Lambda function or an application load balancer as targets for your load balancer. And also when configuring your target groups, you want to select the VPC, so you find resources in that VPC which will be used for the configuration, and you select the ports that you'll be using for routing that traffic based on those ports. And after you've selected, for example, you want to route traffic between our compute EC2 instances, the next thing which you need to do is to register the targets, or you can give a target group name DevOps with Mike target group. Now once you give a target group name, the next thing which you need to do is to register the target. And the target basically means, since we have selected EC2 instances, or we have selected instances as a type of targets which you want to use for our load balancer, we are now going to register. I don't have any EC2 instance running in this region, that's why we don't see any instance popping up. But if you have EC2 instances running, you can configure them as targets, and you'll be used to ensure that your load balancer routes traffic to these target instances which you specify in your target group. So that is how you can configure target groups on AWS. And once you configure your target groups, the next thing which you need to do now is to attach this target group in your load balancer creation. So when you're creating a load balancer, there are key things which you should know as far as creation of a load balancer is concerned. You can have, AWS has 3 principal type of load balancers. The very first is the application load balancer, we have the network load balancer, and the gateway load balancer. So once you're going in for the interview, you also want to know more about load balancer types. Now application load balancer basically helps you to route traffic between your application using HTTP requests, while the network load balancer is routing traffic based on the network particular or network protocol. And then the gateway load balancer can be routing traffic between resources. So you want to take note of these various load balancer types. Now most often they use the application load balancer for configuration. So once you're building your experience, you always want to play around application load balancers. Now once you're configuring your application load balancers, these are some key things which you must have on the basic configuration. You configure the name of the load balancer, you configure the network mapping, which network does it belong to, which VPC, which subnet, which security group, what listeners or which pod will it be listening to, and then you can configure some other additional services, and after that you create your load balancer. So this is a summary of application load balancers, and you can use them and it's a very important resource as far as networking is concerned on the AWS cloud.
Now the next networking service which you have on the AWS cloud is the AWS CloudFront. CloudFront helps you to serve your content closest to your clients. Okay, so assuming you have your resources hosted in a region, maybe in the United States, and you want to serve that same resource to clients in Europe without necessarily deploying a lot of servers in Europe, you can use what we call CloudFront distributions. So CloudFront distributions is one of the main content delivery network services which AWS has to ensure that the static application, especially static websites, they are hosted closest to your end users. And well, a lot of people use edge locations synonymous to deployments with CloudFront. So you want to check out AWS CloudFront, which we'll definitely be checking right away to know how CloudFront works, especially connecting CloudFront with a static website that is hosted on S3 or in S3 buckets. CloudFront basically is a global content delivery network, CDN. So if you're going to interviews and you want to know more about CDN networks, you want to highlight your experience with CloudFront, and CloudFront gives you that possibility to deliver your content to your users. So basically we see that Amazon CloudFront is what can help you to securely deliver content with low latency and high transfer speeds. So you can use AWS CloudFront, and it comes with, of course, a different billing. You can see different use cases to deliver fast and secure websites. So if especially static websites,
You can deploy static websites on AWS using the CloudFront, and then you can deploy accelerated dynamic content, distributed software, game patches, or stream video live on demand. So if you're working or you're interviewing for a role where they are going to be doing live streaming and all of that, you want to highlight your experience with CloudFront or anything that has to do with static websites. You want to express you want to highlight your experience with CloudFront. Now, for you to work on CloudFront, once you click on this three hamburger menu, you can see other aspects on CloudFront. You can configure telemetry, you can have reports and analytics, security, key management, savings, and all of that. So basically, to create a CloudFront, you just need to click on create CloudFront distribution. Now, once you click on CloudFront distribution, you have to specify the domain or the region where this CloudFront is coming from. Maybe you have stored your static website in an S3 bucket, so you can select maybe that S3 bucket and you give the path of the S3 bucket. And then, well, this is just random. If you don't have any, you don't necessarily need to select. So this is the origin. Choose an AWS origin or enter your origins name, and then you can choose the path, and then you give the default caching behavior, what happens and how the viewer will get or how the DNS will use to resolve traffic. Is it using GET or HTTP or just HTTPS? And then you want to use different caching protocols for your configuration. And then functions basically is what will help to configure the cache behavior of your CloudFront. So this is just the basic on AWS CloudFront, and you can check out documentation on CloudFront and have a basic understanding of how AWS CloudFront operates. So understand CloudFront as one of the networking services on AWS.
Now, the next networking service which you can principally measure on during your conversation as far as networking is concerned is AWS Direct Connect. AWS Direct Connect establishes a secure connection between resources on-premise and resources on your AWS cloud. So if you're wondering how you want to connect your resources on-prem, or if there is a need for you to set up a secure connection between your resources on-premise to resources on the AWS cloud, then AWS Direct Connect is that networking service which you can use. And the last service which we have for our networking is the AWS VPN. Now, the VPN service is just for you to set up a secure VPN between your virtual private cloud and your resources that are hosted on-prem. So AWS gives you that possibility to set up a virtual private network, a VPN, between your resources on-prem and your resources on the AWS cloud. These services you should mention are the case services which you must focus on when discussing your experience as far as networking is concerned. Again, you want to talk about AWS VPCs, you want to talk about AWS Route 53, you want to talk about AWS Elastic Load Balancer, you want to talk about AWS CloudFront, you want to talk about AWS Direct Connect, and also you want to talk about AWS compute resources which you can perform compute related operations on the AWS cloud. If you are not yet subscribed, hit the subscribe button right away and let's get started with knowing these compute services. Compute is one of the flagship areas which AWS sells to clients, and by that, different clients have the various ways which they want to carry out compute operations on the AWS cloud. Now, in this video, I'm going to be walking you through the compute resources which AWS has on the AWS console. So we're going to dive into the console and you just have a feel of what some of these compute resources are. These compute resources are categorized into the AWS Elastic Compute Cloud Service, the AWS EC2, which is one of the most widely used AWS service that has a lot to do with compute at the level of pay-as-you-go model. Compute basically is one of the most on-demand compute resource which AWS offers, and when you're looking at AWS compute resource, you want to look at some key areas around auto-scaling or scaling compute resources to meet your traffic requirements. You equally want to look at how to manage traffic into your compute resource by auto scaling. You want to also look at how to manage traffic into your particular infrastructure by load balancing. AWS also has the AWS Fargate. Now, Fargate is AWS way of running compute serverlessly, because some companies actually have servers and it spend a lot managing servers, to configure these servers. If you don't want to have the stress to walk through configuration and management of these servers, you can pass on all responsibilities to AWS and they will take care of all these server management and updates and security and all of that, and that is done by the AWS Fargate service. So Fargate is serverless, management is done by AWS, and you just provision
resources on the Fargate Compute Cloud by AWS. Now, the next category of AWS compute resource which we have is the AWS Lambda. Now, AWS Lambda is a service where you can run compute. Basically, developers don't necessarily need to provision an EC2 instance or a particular infrastructure requirement to run their codes. So with AWS Lambda, you pay only for the time which your code is being run. You want to check out AWS Fargate, AWS Lambda for serverless processing of application code. Now, the next AWS compute service which we have is the AWS Elastic Container Service. Elastic Container Service is the management of containerized applications on AWS, and you can manage your containerized applications on the AWS Elastic Container Service. Now, this Elastic Container Service has the EC2 type, like that which is based on the Elastic Compute Cloud, and we equally have the Fargate type, that which is based on the AWS Fargate. So as far as Elastic Container Service is concerned, you can manage containerized applications with the EC2 type Elastic Container Service or with the Fargate based Elastic Container Service. Now, the next category of service which you can use for your compute is the Elastic Beanstalk. Elastic Beanstalk also helps you to manage your applications, especially mobile applications on AWS with the Elastic Beanstalk. And equally, we have the Elastic Kubernetes Service, the EKS. Well, Elastic Kubernetes Service is one of AWS major container orchestration services. The container orchestration service, Elastic Kubernetes Service, enables you to perform orchestration of your containers. So if you want to bring Kubernetes to the AWS cloud, you're thinking about AWS Kubernetes Service, the EKS. That's just a summary of the AWS compute services which I recommend you to know if you are a starter or if you want to ace yourself for your interview. So play around these services and let's dive right into the console so I can give you a feel of all these services. Right away, we are going to start with the Elastic Compute Cloud Service, the EC2 service by AWS. And here we are on the AWS console. The AWS Elastic Compute Cloud has various key things which you must know. We have the EC2 instances. Now, EC2 instances basically refer to the way which you can create compute resources, and there are various instance types which you can, of course, do your personal research and know about them from the AWS documentation. I shared a link to how you can get AWS documentation, so you want to check our previous video on how to get AWS free resources. Now, on the AWS Compute Cloud, we can have AWS EC2 instances. Basically, these are the ways in which you can have your compute resources. You can actually launch an instance. Basically, you can create an instance, or you can migrate a server to AWS cloud. Now, there are various instance types which AWS has, and once you come to the AWS compute portal, you can know there are various AWS instance types based on the particular requirement which your application has. Then equally, as far as AWS, so there are various instance types that AWS has that match different specifications based on maybe the number of virtual CPUs, the architecture, the memory, the storage type, or the network performance. These are some criteria which AWS uses to classify their various storage instances or their various instance types. And then equally, we can have instance that's already been launched before, or what they call launch templates, which are maybe pre-configured instances that already have some kind of dependencies and applications already running on them. And then we have spot instances, reserve instances, dedicated hosts, scheduled instances, and capacity reservation. So these are the various type of instances which you can have on the AWS console. We equally have AWS images or Amazon Machine Images AMIs, which basically are the operating systems which you use to launch your EC2 instances. Now, there are different types of Amazon Machine Images. We can have images based on the Linux operating system, based on the Ubuntu, based on the CentOS, based on Windows, based on Red Hat, based on Mac OS. All of these gives you the ability to launch your operating system or all your EC2 instance based on a particular operating system type. So that's why we have the AWS Amazon Machine Image. You can equally have the Amazon Machine Image catalog of resources or of AMIs that you've already created. Maybe those you've created by yourself, like this, for example, are AWS AMIs that are already available for you to use on the go. We have Amazon Linux based on the Linux family. Like I said, you can have instances based on Linux, Unix, on Windows, based on the architecture. You can have instances which you've created. You can have instances on the AWS marketplace. You can have community instances. So these are all the categories, or basically the catalog of AWS instances that are available. The Compute Cloud Console, you want to also take note of the Elastic Block Store, EBS, which is one of the key characteristics of EC2. We have EBS volumes, where these are actually the storage types. You maybe want to have a compute capacity of 20 gigabyte of storage, or 50 gigabyte, or 100 gigabyte, or whatever, 1 terabyte. You actually do that by configuring the AWS EC2 EC2 volume. So you can have different volumes of different types. You can actually create a volume to meet your capacity requirements. If you want to actually move this volume from one AWS region to the other, you can create snapshots. Snapshots is one of the ways which you can keep track of your current volume data, or if you want to migrate this particular EBS volume to another AWS region where you can launch a new EC2 instance from, you want to do that by using snapshots. And well, the lifecycle manager equally helps you to actually automate the creation, the retention, the copy and deletion of your snapshots and your AMIs. Now, snapshots is one of the security postures which you can use to make sure that your data in your EC2 instances are always safe and secure without you losing track of data. Now, as far as security on compute is concerned, we have the AWS security groups. Of course, EC2 instances, security groups are like firewalls, kind of preventing unauthorized access to your AWS EC2 instance. So you want to configure security groups to help you manage inbound and outbound traffic, like traffic that gets into your instance and traffic that leaves your EC2 instance. So you do that by configuring your security groups. You can actually create a security group. You can add security group rules, which traffic or which IP address you want to enter into your EC2 instance, or which IP address you don't want to enter into your EC2 instance. So you do that by your security groups. Then equally, we have the elastic IPs. Like if you want to have a fixed IP address for your EC2 instance, you can get that with the use of an elastic IP. Now, elastic IP, mind you, are services that are costly. So once you have an elastic IP, be very careful because it's going to cost you if your account is not actually a paid account. Then we equally have placement groups, the way you want to group your EC2 instances. You equally want to take note of a key pairs, because key pairs is one of the ways which you can use to log into your EC2 instance for configuration, maybe by SSH, like secure shell, a secure way of getting into your EC2 instance. You can do that by using key pairs. So you want to check that out. Then equally, as far as EC2 is concerned, you want to check out their load balancing. Load balancing, like I said, is the way which you manage traffic that comes into your set of instances or out of your EC2 instances. So that is done by the EC2 load balancing. And for you to set up a load balancing architecture or a load balancing technology for your EC2 instances, you must put the instances maybe in a group where they call target group. So configure a target group that consists of a fleet of EC2 instances that are then managed together, or that are then managed for you to effectively manage traffic distribution between those fleet of instances. The elastic load balancers are actually what enable you to scale the capacity and automatically meet the requirements of your incoming traffic. If you're working on EC2, you equally want to manage the scaling of your already existing EC2 instances, or you want to manage how traffic will be coming to your EC2 instances. You can do that with the use of elastic load balancers. Then equally, the last thing which is very important for you to master on the Elastic Compute Cloud is the auto scaling ability. Now, auto scaling configurations basically is the ability for you to manage the creation and deletion of EC2 instances in your particular account. So if you maybe have an application that is requiring maybe a particular memory or a particular storage, and you want that limit to vary with your traffic, you can do that with the help of auto scaling. What amount of traffic or what number of EC2 instances do I want to add when the traffic is high on my network, and which number of EC2 instances do I want to reduce when the traffic is low on my network? So you want to make use of auto scaling functions. And for you to set up an auto scaling function, you need to first put a launch configuration where you configure the number of EC2 instances, the type of EC2 instances, your desired capacity, your minimum capacity, and your maximum capacity, and then you can use that to orchestrate or to manage your fleet of instances. So that is it for your AWS EC2 console. You want to make sure you check these services out. Use your get a free tier account, practice around these services. The next service for compute is the AWS Lambda. Lambda helps you to run code without thinking about servers. But with Lambda, we don't have to manage the server. So pay only for the compute time which you use running your code. So there's no charge when your code is not running. With Lambda, you can run your code virtually with any type of application or backend service with zero administration. It works by you maybe inserting your code based on your application code language. Maybe you have coded your application in .NET, in Go, in Java, in Node.js, in Python, in Ruby, or in any other custom runtime. So you want to use AWS Lambda to test your code. Basically, they use AWS Lambda mostly for maybe data analytics processing, where you want to run very rapid tests on your data, or if you want to configure maybe mobile backends to test how your applications will work, or maybe when there's only an API call on your application, you can think about using AWS Lambda. So take note of AWS Lambda as a service that it's actually serverless. If you want to mention about serverless service on AWS, first thing should come to your mind, we have the AWS Lambda service. We also have the Elastic Beanstalk. Elastic Beanstalk is an end-to-end web application management. So you actually want to effectively manage your web applications hosted in any programming language, maybe be it Java, .NET, PHP, Node.js, Python, Ruby, Go, and any other Docker familiar servers. You can use the Elastic Beanstalk service. So with that, you can create an application, you deploy easily, and then you have your application easily running. The Elastic Beanstalk service is interoperable with AWS Lambda, with Lightsail, with Amplify, with API Runner, and with the Fargate service. So this is one of the major services you can use for your compute related task. Once you set up maybe an Elastic Beanstalk application, the next service which you want to think about as far as compute is concerned is the Elastic Container Service. And like I said, it's a service for management of computerized applications and is fully managed container. So Amazon ECS is highly scalable and fast container managed service that makes it easy to run, to stop, and to manage containers in a cluster. For you to have a AWS ECS running, you must set up an ECS cluster. You can have different clusters in your ACS infrastructure. Basically, a cluster is a grouping of resources, grouping of your task definitions, grouping of your services, grouping of your task in an organized way. So even namespaces. So you want to group all your resources in an ECS cluster. Then namespaces basically is ways which you can use to kind of subcategorize these resources. Maybe if you are deploying an application that has maybe a home page, a about us page, a buy now page, or a blog page, you want to use namespaces to actually logically group these resources to avoid redundancy and to easily access what particular resource. So we equally have task definitions that define how your tasks actually are going to be running, the specifications of your containers and all of that. And then we equally have the ability for you to manage your repositories. I didn't mention Elastic Container Registry, ECR, but you want to make sure you check out ECR. ECR is one of the ways which you can use to store container images on the AWS cloud. So once you have a mastery of the ECR console, you create your images maybe with your code build. If you are running a DevOps pipeline, you might create those images with code build, and once the code build is complete, you may want to store the images in a repository system. The ECR service is interoperable with your ECS service which you are looking now, because once you maybe have an application that has already been created and you have the latest version of the image or the latest version of the application, you can then pull that image from your Elastic Container Registry and you deploy into your ECS cluster that will automate the creation of your ECS task or your ECS service that runs that application. So the ECS service actually has the service that is based on Fargate, so you can manage your applications in a serverless way with Fargate, or you can manage them with you actually managing the creation and the deletion of the servers with the use of EC2. So we have the ECS EC2 type cluster and the ECS Fargate type cluster, and each of them, like I said, deals with the area of, or the intricacy of both of them is around the level of management. If you want to have more management abilities, you want to use the EC2 Elastic Container Service. But if you want to have less management capabilities or less management overhead, you maybe want to use the AWS ECS Fargate service. Basically, I already have a cluster running, currently doing some application. I'm currently building a CI/CD pipeline, so I'm using the ECS service to deploy my application. You can use the ECS service, you can create a cluster. With the cluster, you create your namespaces, you create your task definitions, and you can set up other things. So this is just basically it about the Elastic Container Service. The last service which we are going to be looking at is the Elastic Kubernetes Service. Yes, Kubernetes is what is most needed in the industry. You can't be successful as a DevOps engineer if you don't know container orchestration with Kubernetes. And AWS native Kubernetes service is the Amazon Elastic Kubernetes Service, the AWS EKS. Now, the Elastic Kubernetes Service actually is a fully managed control plane service where you can create your Kubernetes clusters like you regularly do on the Kubernetes, where you create your Kubernetes cluster, you create your Kubernetes service, create your node groups. So basically, how does the EKS work? You basically set up your EKS cluster and then you deploy worker nodes on the EKS cluster. You connect to your Kubernetes by your Kubernetes controller, your kubectl, where you run Kubernetes declarative and imperative codes, manifest files, or whatever way which you've used to put up your Kubernetes architecture, and then you can then run your applications on the AWS Kubernetes service. Now, why you want to use Kubernetes is AWS native. It's kind of helps you to run your microservices on AWS cloud, so it may also help you to do batch processing. Now, as far as the AWS Kubernetes service is concerned, you can equally link it to your Elastic Container Registry for you to pull images to and from the AWS ECR. Once you create an Elastic Kubernetes cluster, you can then configure manage groups with the use of AWS node groups and nodes, which corresponds to the key functions or the key architecture. Because if you take your Kubernetes architecture, you want to look at your Kubernetes nodes, your control plane, your worker nodes. You only want to look at your services, your pods. Very brief example: you create a cluster, you configure the cluster details, maybe the name of the cluster, basically the login. So for you to configure a cluster, there are some key things: how you want to manage your cluster, which Kubernetes version are you running on. You also want to configure your networking, which Kubernetes network. If maybe you've already created your network with CloudFormation or with Terraform, you can then use the network which you've already created. You can equally configure login for your Kubernetes cluster. You want to log maybe your Kubernetes logs in CloudWatch, or you want to export the logs from CloudWatch to maybe a login service like Prometheus, where you can set up your dashboards with Grafana. Then equally, we have the select add-ons. You can have some Kubernetes add-ons for your cluster, which you can set up, and then you review and create. Once you create, you can then perform services like creating new namespaces, creating node groups, creating Kubernetes deployments, creating pods, and creating namespaces, secret maps, and config maps, and all of that. So that is a very brief about Elastic Kubernetes service. I hope this video you're able to understand the basics of some of the compute resources which AWS has, and like I mentioned, these are the key resources which I recommend you to know before you go in for your DevOps interview, or these are the services which you should be able to master and pitch during every DevOps interview or cloud computing interview which you have. So we want to continue watching this series, because in the next part of this series we will be introducing you to the storage services which AWS has. If you are not yet subscribed to the channel, hit the subscribe button and get subscribed, because more aspects of your DevOps journey will come from us in this channel. And equally, join our DevOps community with a link in the channel description or in the video description. And equally, if you want to book a one-on-one mentorship call with me, feel free to use the links in the channel description and in the YouTube, in this particular link video description, to get started. See you in our next video. If there is a company that is based fully on AWS services and they want to perform continuous integration and continuous deployment on the AWS cloud, what services are available for them to perform continuous integration and continuous deployments? Now, the very first service which we have is the AWS Code Commit. AWS Code Commit acts like a version control system on the AWS platform. Just like we have other open source code management technologies like GitHub, GitLab, Bitbucket, and all the like, AWS Code Commit is AWS native source code management service. And with this AWS Code Commit service, all the code which the developers produce in a local environment can be effectively managed and version controlled in the AWS Code Commit. So let's dive right into the console to see what AWS Code Commit looks like.
Once you're on the dashboard, all you need to do is to search for the service Code Commit, and you'll see Code Commit, and it says Code Commit to store code in private Git repository. So it's AWS or native repository which you can use to manage code. Now, once you're logged into the AWS Code Commit on the platform or on the console, we have AWS Code Commit can help you to create secure repositories for sharing your code in the cloud. So there are different things. You can manage repositories, you can manage approval roles, and well, all these services are found under the developer tools on AWS platform. So AWS, one of the benefits of Code Commit, it's fully managed, it's secure, highly available, and you can store anything. And then you can use related service like CodeStar, Code Pipeline, AWS Cloud9. So these are some applications which can work with AWS Code Commit. So to create a repository on Code Commit, it's pretty straightforward. All you need to do is to click on Create Repository. Once you click on Create Repository, all that is required of you is to carve a repository. Let's take, for example, DevOps with Mike demo. So let's take, for example, DevOps with Mike demo repo, and all you also have to do is, after putting the name, it's optional for you to add a description to the repository. So oftentimes I can just copy the name and use as the same description for the repository, and then you can enable Code Guru Reviewer if you're interested. That's actually optional. Once you have put in these basic details, of course it's used to create your own repository system on AWS. So all you need to do is to click on create. Once you click on create, AWS is going to provision a new repository for you. So basically the new repository has been created, and as you can see it says success, repository successfully created. You can create a notification rule for this repository. Basically, if you have to commit new codes into the repository, you might want to configure that using a service like EventBridge or CloudTrail. Now also, once you set up the repository, just like GitHub, there are ways which you can use to connect to the repository. So you can do a Git clone if you want to have. You can connect with this repository through HTTPS, which is one of the main ways, and they give you all the steps which you can use to connect to this repository. So you need to have a particular Git version. You need to have Git credentials, which you can create with the IAM user. So you need to create code commit credentials for this IAM user on AWS IAM, and then you can probably clone this repository to begin to perform changes. Now, if you want to SSH into the repository, you have different options. If you are using a Mac operating system, these are ways which you can use to SSH into the repository. These are ways which you can use to SSH and have access to commit changes into this repository. If you are equally looking for the clone URL, you can also get them from here. So basically, code commit is one of the ways which we use on AWS to manage source code. So the equivalent of this code commit repository is we have GitHub, we have Bitbucket, and all the others which you mentioned. So that is it for the AWS code commit.
The second AWS CI/CD service which I'm mentioning in this series is the AWS Code Build. AWS Code Build. And AWS Code Build is a build service on AWS which helps to build source code from these developers into fully managed deployable application or software packages. So rather than you provisioning build servers on AWS, perhaps maybe you launching an AWS EC2 instance and installing maybe Apache or Marvel or Gradle, with the AWS Code Build service, you can compile or you can package or you can build code built by several different programming languages. And also AWS Code Build gives you the ability to integrate other build tools like Apache, Maven, and Gradle, and other even open source technologies like Jenkins, which you can integrate to your build service. So for you to perform build service for your application source code to the final package, we have the AWS Code Build service.
So we are on the AWS console, and now we will look at the AWS Code Build service. Now Code Build basically gives the ability to build and test code. So after typing Code Build here in the service section, you see different options, and we have the option of Code Build. Now once you click on this Code Build, it will take you to the Code Build service which we have on AWS. So the Code Build helps you to build and test code with elastic scaling, and you pay only for the build time you use. So you don't necessarily need to pay for every time your code is running. All you need to do is to pay for the build time which you use. And these are some key benefits: elastic scaling, extensible pay as you go, and you can integrate it with Code Deploy, Code Pipeline, and Code Star. So once you're on Code Build, you can actually have build projects which are running, build history for projects which you've already created, and then you can set up some other metrics. And equally, you should note that the Code Build service is under the AWS developer tools. Now for you to create a build project is pretty straightforward. You click on create build project. When creating a build project, you need to specify some key requirements, and we are going to be seeing some of those things very briefly. So for example, if I want to create a build project to maybe do a continuous integration and continuous deployment pipeline, I can set up a build name for probably DevOps with Mike Code Build project. Now I actually just copy this name and use the same description. If you want that this build to be like, you want to build as one batch rather than building multiple or individually, you can enable batch build. And then equally, as far as setting up Code Build is concerned, you must specify where the source code is coming from. So if you want to check on AWS, you can store your source code, which will be built using AWS S3, using Code Commit, using GitHub, using Bitbucket, and even GitHub Enterprise. So assuming you store your code in your Code Commit repository, it's going to scan the AWS environment in this region for repositories which you already have. So assuming I take, for example, this particular repo, now once you did a commit on that repository, you must have a branch which is specified. So the branch which was used to push this particular repository was the main branch, and then there are some key things. We want to use a managed environment to run the instance, or to run the build, or you want to customize your own. So basically, oftentimes you just need to use the Amazon Linux, which is already pre-configured, and you want to use the standard runtime, and you can choose any recent Amazon Linux image. Now equally, you can specify if you have your code build, or the build pipeline, or the build script, the script which you'll be using, the build spec.yaml. If you have to perform build on Docker images, it's important that you enable this flag for Docker images, and equally you need a service role which will have to be attached to that. Then now the build spec file is the manifest file which will have all the build instructions. So once you must specify a build spec file. Now in my code commit repository, there's a file called build spec.yaml. That is why I just need to copy that file, or that name, and put here, and that will signify the same. I equally have that file. So if you have some other specific or additional configurations, you want to specify the VPC where it should run. If you've passed some environment variables in your code, you need to specify all of them here. And then equally, once you've set that all up, if you want to enable login every time a build operation takes place, you can configure login with CloudWatch, and you can store the logs with S3. So it's just a very brief overview of what the code build service look like. So once you've set up all the necessary requirements for code build, what is left for you is to click on create a build project. Now once you create a build project, of course you have successfully created the build project, and you have details on the build. If you had to maybe share this build project, you can share, you can start the build, you can see the build history, build details, build triggers, and all of that. So assuming you want to build this project, you click on start build, and you can equally configure a notification for the particular repository. So when you click on start build, it's going to show you in progress, and then equally it will give you the logs. It will show the activities, or if you are running a given set of codes, the logs will show you all the various instructions that are being implemented in your build spec file. So basically, this is what we have as far as AWS code build is concerned, and we can use this code build for our build servers in a continuous integration and continuous deployment pipeline. There's a whole project which we did with AWS CI/CD, which you can equally watch. So that is it for the AWS code build service.
Now, assuming your code has been effectively built and we now have the deployable application packages, you can store these application packages in the AWS Elastic Container Registry. So the next DevOps tool, or the next CI/CD tool which I want to mention in this series, is the AWS Elastic Container Registry. And the Elastic Container Registry gives you the ability or the possibility to store final container images of your already built application files. So immediately, if you're implementing a CI/CD pipeline, immediately code build service has effectively performed a build on your application source code. You want to store the final built images in a service like the Elastic Container Registry.
The Elastic Container Registry service, the ECR, is a service which you can use to fully manage Docker Container Registry, or where you can share and deploy containerized applications. So this is AWS native container management service, as we mentioned, and we just be going straight into the ECR service. So once you click on this, it takes you to the Elastic Container Registry service, which, like I said, it helps you to share and deploy container software publicly or privately. And you can see here how it works. You write your code, you store in ECR, or once you perform a build using a service like code build, you store the final image here in ECR, and then you can run these containers, or these images as containers, and orchestrate them with different orchestrating services like ACS, like Elastic Container Service, or you can even run them on-prem. So these are some of the key benefits of the Elastic Container Service ECR service. Now, once you're here, you can equally click on the hamburger menu. You can have a private registry, you can have a public registry, and you can view all your repositories on the AWS platform. So all you need to do to have a repository is to click on create or get started. Once you click on get started, you can specify if the repository is public or private, and then you have a URL that is given by default by AWS, which you can use to reference. So once you have this, you just need to configure your name. Say, let's say DevOps with mic repo. So let's take DevOps in mic repo. Now once you've given a name, all you have to do, if you want to scan on push, like for every push that is being done, you want to scan the code, or you want to do perform encryption, all these are services you can enable. Once you've put in all the necessary information, all you need to do is to click on create repository. Now once you click on create repository, you successfully create the repository and you have different uses. Now what is very important for you to note is the repository URI, because this is what you can use to reference this repository in any given pipeline which you are building. And equally, you can view push commands. That means if you want to push image to this repository, so once you click on push commands, it will give you the various steps which you can use to push image to this particular repository. Once you have an image, you can build the image using docker build command. You can tag the image maybe using docker tag command, and you can equally push the image to your Docker Hub repository or to this ECR repository using the docker push command. So that is how the ECR can be used as part of the continuous integration and continuous deployment pipeline.
The next CI/CD technology which I'm mentioning in this series is the AWS Code Deploy. And AWS Code Deploy is AWS based deployment service which you can use to release your application code that maybe you have installed in your Elastic Container Registry or from your build servers or from your build pipelines into your environment or into your production environment. Okay, so the deployment service, which is AWS native, is the AWS Code Deploy.
Now the AWS Code Deploy is to automate deployments. After you perform your build of your code and you have the container image, you might want to perform deployment of this code into a given set of environment. So once you click on Code Deploy service, it will now give you the opportunity to manage your deployment. So it's a service that helps you to automate deployment to maintain application uptime, and it's kind of like free if you're running it on EC2 or Lambda, or you can run it on-premise at a given rate. So these are some of the ways which you can use to run the code build service. So once you want to create an application, all you need to do is click on create application. So once you click on create application, you need to give the application name. Let's say, for example, DevOps with mic app. Then you choose the compute platform. Do you want to run it on ECS or on-prem or Lambda? You choose Lambda, for example, and all you have to do is select create application. Now once it's successfully created, you need to now create a deployment group, where the deployment group is where you add all the compute resources. Once you click on deployment group, you now have to specify all the requirements which CodeBuild will use to perform the deployment. So this is how you can use CodeBuild as one of the services to push the deployment of your application or of your images in an automated CI/CD pipeline.
The last AWS CI/CD service you want to mention is the AWS Code Pipeline. That is one of the flagship CI/CD tools which AWS has for the implementation of a continuous integration best practice on the AWS environment. So if you want to build a continuous integration and a continuous deployment pipeline in AWS Code Pipeline is that service for that purpose. Now with the AWS Code Pipeline, you can integrate your source code from a service like AWS Code Build, and you can equally specify your code build service like AWS Code Build, or maybe if you're using an open source build server like Jenkins, you can specify Jenkins as your source for the code build. And equally, you have to specify your deployment, how you want to deploy your package or your already processed application. It might be using the AWS Code Deploy service, or using AWS Elastic Container Service, or using AWS Elastic Kubernetes Service. Whatever the deployment strategy is, you specify your deployment service, and the pipeline performs that continuous integration between the source code right from the developers through AWS Code Commit up to the deployment, maybe with AWS Code Deploy or with AWS Elastic Container Service. Thus, AWS Code Pipeline effectively completes the CI or the continuous integration of all the processes of your CI/CD tool.
We're on the AWS console, and now for us to see how Code Pipeline works, all you need to do is be on the services section. You can type Code Pipeline. You can type Code Pipeline, and like you said, Code Pipeline helps you to release software using continuous delivery. The pipeline actually gives the communication or interlinks or connects all the processes in the continuous integration and continuous deployment. So once you click on create pipeline, as you can see, it helps us to visualize and automate the different stages of your software release project or release process. Now, as far as the pipeline is concerned, it has many configurations which you need to do, and it's like I said, is the last mile where you connect all the dots between continuous integration and continuous delivery. So as you click on create pipeline, you need to configure the pipeline name. So let's take, for example, DevOps with my pipeline. So now once you have the DevOps with my pipeline, you need to configure, and you don't necessarily need to configure that. You can just add this new service role, and then you can take next. Now you must specify a source where will code pipeline receive all the source codes that is going to be performing the orchestration with. So maybe you store your code in code commit or ACR or Bitbucket or whatever the case, you must specify. So in our case, we store our code in AWS code commit. Once you're on code commit, you need to specify the repository name. So let's say we choose code commit as a source provider. You need to specify the name where you store the code, and then you need to give the branch where you have a code stored. Basically, to set up the code pipeline, you need to configure the source stage, the build stage, the deploy stage, and the review stage. You need to give a pipeline name. Take, for example, DevOps with Mike. DevOps Mike pipeline. Now, once you click on DevOps Mike pipeline, next you need to configure the source. You can have the source on code commit, ACR, S3, Bitbucket, and so on. So let's assume you use code commit as your source provider. That is where you basically input all your artifacts or your files, all your application, your pipeline scripts, and all that. Now, once you select code commit, you need to specify all the various repositories and all of that. So basically, this is how code pipeline is, and this is one of the main services which you can use for your continuous integration and continuous deployment on the AWS platform.
If you're not yet subscribed, hit the subscribe button right away and get subscribed to our channel. If you are a returning subscriber, thank you very much for watching our content. Thank you so much for sharing our videos. Thank you for all the likes and all the thumbs up. It's helping us to produce more of such content that can help a wider audience. And well, you want to join our DevOps community with a link in the description, or that will give you the opportunity to network with other DevOps engineers and have the opportunity to equally receive free resources which I am sharing in the DevOps community. Also, if you want to book a one-on-one mentorship call, or if you want to get yourself ready, or you want to ace yourself up for your interview, you can hit the description and get a one-on-one mentorship call with me, and I'll be available to help you in your journey. Be a part of the community and have access to these free resources which I have for you. Thank you for being there as a subscriber, and if you're not yet subscribed, hit the subscribe button right away, and let's build and let's grow together.